All right, dual enrollment pre-cal students, we are finishing up our first quarter here, and so I said that I would film this final lesson for you guys so that we didn't have to meet this coming Tuesday, the 26th. So this will be your lesson for that day. It shouldn't take us too long, and then we'll start preparing for the midterm, and also there's a quiz for Chapter 3. But let's go ahead and get started with this. I think everybody got these notes because we've already started this page here. So if you want to stick around and watch this part of the lesson again, you can, or you can fast forward. I'll put in the comments where you should fast forward to if you want to go ahead and get to this next section here where we're finding the area of the rectangular region. So you can fast forward, just look for that in the comments, okay? But let's go ahead and get to this. So when we're solving, we've been talking about quadratic functions in this chapter. That's what it's all been about. And so we talked about sometimes a quadratic function can be used in application problems. You probably did this in iMath too. The vertex is quite important for that. So inside of this space right here, the y-coordinate of the vertex, when a graph opens upward, that's important. When a graph opens upward, so it's going this way, okay? But that y-coordinate is what we would say is the minimum, okay? So that's what that's going to change into. And then the y-coordinate when the graph opens downward, so we're opening downward, is going to be that maximum point, okay? So depending on what you're trying to find, that is... either one of those could be important when answering the question. So one of the typical examples you see in quadratic application problems is this idea of projectile motion. For those that take physics, we put this -16 in the front of this quadratic, and what that represents is the acceleration of gravity, which is -16 feet per second. Inside of this formula, it tells us that what it's doing is calculating the height. So we have S of t here. So S of t is the height. T is time in seconds that we see here. H naught, as we might call it, represents the initial height of whatever that object is. It's where it starts when it starts going in motion, okay? Whatever that height is. And then VO represents the initial velocity in feet per second. So whenever you have a upward velocity, then it's V0 greater than 0. So it's a positive number. And if it's going downward, then it's a negative number. Okay. Now we go ahead and we're going to apply this immediately in a context. We're talking about baseball down here. So it says Aaron Judge hits a baseball straight up with an initial velocity of 80 feet per second, about 55 miles per hour. And then it leaves the bat with an initial height of 3 feet. So you can imagine he's swinging the bat, boom, he gets a velocity of 80 feet per second. And then that contact point with the bat is at 3 feet off the ground. So write a formula that models it. Well, luckily I can just paste down here. So I'm going to do that. I'm going to paste, if I can get it to work. I guess it's working. 1 second. Let me get this situated. Okay, so I got it more or less now where it needs to be. So this formula here, as you can see, this is what you should be writing in your notes. Well, it tells us the initial velocity is 80, so we're going to plug in 80 right here, and then we're going to have the initial height of 3 feet. Okay, so there is our formula for this baseball that is being hit. Now, always with these, we have a couple options. So, for instance, we could just type this in. We could do this formula, and it says how high is the baseball after 2 seconds. Well, the baseball after 2 seconds, that means we're just taking this and we're plugging a 2 in here, okay, everywhere that there is a t. So we'll just rewrite that here, and we could easily calculate that, and this would be done, but I would love to show the graphical way of doing this as well. So we're going to go ahead and get this typed in, -16. We cannot type a t. We're going to have to put an x in here to the second power. Okay. And then it is, we look back at our formula, which is back here on our notes. We have plus 80 plus 80t, we're going to use x, and then plus 3. So plus 80x plus 3. Okay. Now you'll notice this is not scaled very well in our graph. So if you need to pause the video to make sure you've got this typed in, go ahead and do that. If you need to like split your screen up, you can press the Windows key on your keyboard and then to the right, which I should have done with my notes as well. So you can see how I can split my screen up like this. Sometimes that can be pretty handy when you're working it on two apps inside of your notes. I'm going to move my camera over here so that we can see the graph. But so we have our graph over here, and we would like to get it to fit really well in our screen. And I think we've talked about that plenty of times in class. All you need to do is click the gear up here and get a table. That's really what you need, is a table. And then you just click zoom fit and it fits it. Now it's showing these points here, but let's scoot over and now we get a really good vision of what this parabola looks like. So remember, the x-axis is time, the y-axis is that height at a particular time. And so we're looking for this 2 seconds right here. There it is. The x value of 2, we get 99. We could also type in, we could go 3 and then reshift it. We could go 4, 5, and look at that. We're seeing all these points, and we can fit those in to our graph here. So looking at the picture is pretty nice. So over here in our notes, we're going to type equals 99 because we know that that's how high that is after that much time has passed. Okay. Then it says find the maximum height. Well, we just talked about up here how the y coordinate of the vertex is the maximum height. So how can we find the vertex of this? Well, we saw how to do it sort of by hand analytically, but we can go on Desmos and it just easily shows it to us. You see that? It shows us the vertex if we just hover over there. So we know we're going to type this in, or I'm going to type it, you're going to write it. At 2.5 seconds, the ball will be at its maximum height of, and we see the height right there. We're going to say 103. And so 103 is going to be as high as that ball is going to get, and then it starts to descend back to the ground. As we can see here on our table, we can see how as x is increasing, it goes up, 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 and it goes down. But we noticed that we did not get our vertex. So I type in 2.5, it will give it to me though. Okay, so we can type anything we want in there, but we see it right there. Okay, all right. So let's move on to this idea of finding the area of a rectangular region. Okay. So it says a farmer wishes to enclose a rectangular region, and he has 120 feet of fencing and plans to use one side of his barn as part of the enclosure. Let X represent the length of one side of the fence. Okay. So over here in this space on your paper, we're going to draw this. So to start, let's draw we're going to pretend like this is the barn. What is this text? Oh, it's ink to shape. Hold on a second. Let's see. Draw. Okay. So this is the barn. Let me get this written. Okay, I got it to work. So this is the barn wall. Let's just pretend like that is the barn wall. And check it out. We are going to draw an imagined rectangular fence up against this wall. Okay, so it's always important to like draw out what you're thinking that it's asking you to show. Okay, so zoom in here. Okay, so we have this barn wall. Now let X represent the length of one side of the fence. Okay, well, we're going to go ahead and we're going to write on here, we're going to call this the length of the fence here. And we know that these are going to be the same, right? Because it's a rectangle, so it has two opposite congruent sides. So that is X. Now, this length side here, we know that we have a total amount of fencing around this to be it's going to be 120 feet total, right? So we start with 120 feet, but we know that we're going to be subtracting whatever these two are combined. So I'm going to subtract 2x from it. So that's going to be the length or the width here. Okay. That's going to be the width here. So we want to determine a function that would show this. That's what we want to do now. Okay. So I'm going to type in here. I'm going to put an equation in here. Okay. And we're going to say a function a. So we're going to call this a of x equals, and you can write this down as you go on. Well, what do we have to do to get the area of this, right? No. Do we want that represents the area of the region. Okay, so we do want the area. So we know that it's x times this 120 minus 2x. We know that it's this down here. This x times this function down here. Now, I don't really need that. I will show it. I'll keep it there, but we know that we're multiplying those two together. So this would be x times 120 minus 2x. I hope that makes sense. Be sure that you ask me questions, like type me an email and say, hey, could you somehow explain that to me a little bit more in depth? I'd be glad to. But hopefully, if you want to pause it and just sort of reread the question, see how I built this, I'd recommend you do that. Okay. So what are the restrictions on x? Basically, remember, x is domain. So how do we talk about the domain of this? Well, how large could x be and how small could x be? Well, could x be a negative number? No, it couldn't, because you can't have a negative length. Could x be 0? What happens if it's 0? Well, you don't get a fence, right? So basically the domain is, it tried to make an emoticon. The domain is 0, like that, but not including 0, right? Any value greater than 0, but when does it, if I increase those x's as they get, they sort of get dragged down, if they keep extending, when do we run out of fence to where we don't have a rectangle anymore? Well, we run out of it when we use all 120 feet of fencing. Well, that means that this one would have to be 60 and this one would have to be 60. So up to 60. So as long as we keep our fence length on those sides to be about 60 or less, between 0 and 60, but not including those, we should be good. Okay. It says graph the function in a viewing window that shows both x-intercepts and the vertex. Sweet. All right, let's do that. So I'm just going to graph this. By the way, this is a quadratic. If we were to distribute that, let's go ahead and show that. This would be, if I distribute it to 120x minus 2, and then I have to go to my equation editor. We'll do this, 2x squared. That's what it would end up being. And then, of course, if we want to go a little bit further than that, I'm just going to do one more here. We could, of course, rewrite this. We could just flip where these are just to make it look more like a quadratic. And so this is sort of what we end up getting as a final answer. Like that's what our final equation would end up being if it's in standard form. But you could just graph it like this, which actually that's what I'm going to do because it's easier to type. So we're going to go back to Desmos. Let's clear this. Okay. Let me make that small again. Okay. We got our diagram. So let's type this in. So it's x, and then we have 120 minus x. There it is. And let's go ahead and make that into a table, and we see our graphs here. Okay, we need to add a few more points, it looks like. Let's keep hitting enter. We're going to add tons of points on here. We need to see how it peaks and then it falls. Looks like it hasn't fallen yet. Will it ever fall? We're just going to hold enter. Let's see if I... Oh, look at that. There it is. Okay, so we have our parabola here. That took a lot of points, but we're at 57 points. I mean, we could just keep going, right? However, I don't want to do that. I don't want all those points. Oops. Show all rows. Rescale. There it is. That's good enough. Like, we just want to see the overall shape of it. So there's our parabola. And so this is showing how the area is going to change. Remember that x is the length of our fence. And this should be 2x. I messed up. Okay. Hold on. So we need 2x in here. I was like, wait a minute. We said it couldn't be more than 60. So, all right. So there we go. We have that now. So hopefully you didn't do that. I'm going to get rid of some of these points, though. There we go. But anyway, we have our parabola here. So make sure you have that 2x in there. I was wondering why that happened. So remember the domain. Check out the domain. This is exactly what we said. It starts at 0 and goes to 60. It would not make any sense if we went down here because then we get negative areas. Okay? So this makes sense. It says graph the function in a viewing window that shows both x-intercepts. So we have this one, and we have our vertex. Okay, so that is done. Okay, it says interpret 18 and then 5, 15, 12. So did we do 18? No, we're going to add 18 down here. So we're going to type in 18. Here it is. There's that point 18. So how do we interpret this? Well, this is what we're going to say. If the length of the fence is 18 feet, then the area of the enclosure will be 1,512 square feet. Okay, that's what that's telling us. All right, what is the maximum area the farmer can enclose? Well, that would be, let's see, where's that vertex? 30. And if you can imagine, when it's 30, what actually ends up happening is we have 30, 30, and then this would be, what is that going to be? Minus 60. Well, this one's 60. Okay, so this is 30, this is 30. Then there's 60 feet left. So that is actually where it peaks. And most of you might have thought, oh, well, it would have to be a square. But because of the barn wall, this barn wall over here, that one right there, that actually changes this. A lot of times the square is going to have the most area of all the rectangles, but because of that barn wall there, that's what actually changes this a little bit. So be careful with your intuition on that, and this might be an interesting lesson to have observed. But we are going to go down here and answer this question. We're going to say the maximum area is 1,800 square feet with a length of 30 feet. And that will be our X value. So very good. We were able to get that one completed. Okay. Now there is one more that we want to look at. It is this one that's in your My Math Lab. It's just an example problem from there that we're going to work through together. All right, so this problem's a little bit different. This comes from My Math Lab number 14. So it's actually the example in that one. So you're not getting any like new, or I'm not answering anybody's question, I don't think. But this one is different than what we saw here with the farmer, okay, and the barn with the barn wall. So let's go ahead and talk about this. So let's imagine we have it's another farmer, but he wants to enclose a rectangular area, but he's not putting it against a barn this time. But it wants to know what dimensions for the rectangle result in a maximum area enclosed by the fence. So we want the maximum area. This should turn into a rectangle for me. There it is. So we know that if we call this side, we'll call this X, and we'll call this one Y. Okay. We do know that the whole thing needs to add up to 1,000. So we know that if we're like wanted to get the perimeter, by the way, we could set it up like this. And this is exactly how you kind of want to set up your problem when you're working this on your own. Okay. So 2x plus 2y equals 1,000. Now we always want to create an equation in terms of y, right? It's a y equals equation. Just to sort of think about this, remember that area is equal to length times width. Okay. Now, if whichever one we want this to be, it doesn't really matter. But imagine that I call this let's call this the width. Okay, and let's call this one the length at the top. Okay, so this will be length. What we need to do is I need to create an equation a of x, and I need it to just be in terms of x. For instance, the the width is easy, right? Like it's already x. But what am I going to put in here for the length? Well, what is the length? Well, it's y, but I can't type this in Desmos. It doesn't help me to do that. So we need to figure out how to get the length in terms of x. That's what we have to do. Okay, so we already have this cool equation that we've created down here. Okay, so that's what we're going to end up using. So for instance, let's isolate the y variable here. So I'm going to subtract 2x from both sides. That gets rid of this. And I get 2y equals 1000 minus 2x. And then we're just going to divide both sides by 2. And now I've got this term or this expression for y. And we know that this 1002 will divide into 500. And this 2 here will just divide away. And I end up with 500 minus x. So this is actually what will go in to my equation right here. Okay, that's what we're going to do. So let me redraw this. So this is actually 500 minus x times x. And now we can work with that. Like that's an equation that can actually be put into Desmos, which is what we intend to do right now. So we'll pull up Desmos. We're going to do 500 minus x, not 550. And then we're going to multiply that by x. Once again, it's not in our, we can't see it. So we know that we're going to have to turn it to a table, and then we just have to add a bunch of points. So let's see how well that does right there. Not very good. Not good enough yet. I'm going to go ahead and type like 50 in here. It looks like these get out of hand. 50, 75. Let's do 100. This keeps growing like crazy. So this is getting to some pretty intense numbers. By now I can zoom out. Look at that. I think I typed this in, right? That's pretty large. Yeah, that looks correct to me. Oh, and it does make sense. Like for instance, the domain, any of these sides can't be more than 500. So this actually means that we did it correctly when we look at this. So if I can't even see the 0, 0, and 500, 0. So that makes sense. The domain's 0 to 500, which we saw in the last example. But this is what we're after here, right? The vertex. And this vertex here, that's when 250 is the length, but also 250 would be the width as well, because think about it, 250, it adds up all the way all around. 250, 250, 250, and 250. That's 1000. So this is a perfect square. So 250. So the maximum area enclosed by the fence has a length of 250 and a width of 250. Okay, so this is how you're going to want to work this problem. You'll set it up. You may want to draw a diagram for that. Isolate y so that you can get it in terms of x, just like I did here that's circled in purple. And then you make an equation, length times width. And that's all the notes that we have on this, and your homework should be doable for you. The only thing that you have coming up is going to be the midterm. And then, of course, you're going to have to take a quiz on my math lab. Let me pull that up for everybody just so that we see what I'm about to do with that. Let's see. So let's go back here. So on here, move my camera over. Actually, no, I think the camera's fine over here. Let's do assignment manager. You're going to take your quiz, and we're going to make sure that that quiz is before the midterm. So I think this quiz is, let's look at some of the settings here. It is, in fact, 15 questions. It'll take you 20 minutes to do. As typical, I'm going to give you an hour to do it. Okay. We are going to start, we're going to open this up on Tuesday. So this lesson will come out Monday, but you'll be able to take this quiz on Tuesday. I would recommend you do all your My Math Lab first before you attempt it. And then you're going to have until, hold on, not this Tuesday, the 26th. The 26th, you'll have it. We'll start that at 12 a.m. And then it's going to be due we take our midterm on Thursday, so you have 2 days to get that done. It'll be either Tuesday or Thursday that you will be, Tuesday or Wednesday that you'll be turning that in. We'll make that a late entry time here. We'll get rid of the password. You get 1 attempt, and then you have to take it in 1 session. You get 60 minutes to do it. You'll see the time, and you'll be able to review your quiz anytime after submitting. So we have all the settings in here that we need. So we're going to assign that. And so you guys are going to have to do that quiz Tuesday or Wednesday. That's going to be all you need to do. Okay. Reach out to me if you have any questions. If you get stuck on any problems in the My Math Lab on your homework, just use that Ask My Instructor tool. That works really well for me, and I'll be able to reply back to you. So, all right, everybody, we'll see you on Thursday. And make sure, one more thing, make sure that you use that chapter 1 through 3 review. I called it a midterm. It's not a midterm. I'm sorry, guys. It is just your chapter 1 through 3 test. That's what you're taking. So we'll end the video here.